Thank you, Shane. Hey, good afternoon, everyone. It's great to be here. So today, my talk will be about leveraging Spark to democratize data for omni-commerce. So just look at the agenda. So basically, who am I? I'm just going to introduce myself. I have a master's from PRE. At that time, I was working with, playing around image classification problems. It was fun, but I did not get to any application of big data or machine learning till actually I did a startup earlier on, working with Johns Hopkins for treatment risks to predict the patient's probability of the surgery before actually the surgery and get some kind of insights as to what is the survival rate. So that actually, the idea did not fly that much, but it did give me a way to work my way through the big data. So I joined GRE. Before that, I was a part of Zenprise, which got acquired by Citrix, a big exit. It's an enterprise mobility service. So at GRE, I was leading the real-time analytics platform, great experience. And then I went on to found my own startup called INSNAP, which I'm going to talk about in a bit, before it was acquired by Honest. And at Honest, I'm heading up the data engineering group. So I have 10 patents in the area of enterprise security, big data, machine learning. And here are my two kids, father of two, keep me busy. All right, so we all have heard data is the new oil. So my take on that is it's not a panacea or a snake oil, but actually the value it brings to the economy, to our lives, that's what very important, the important part. And we have seen now Amazon just joining the $500 billion club along with Alphabet and Apple. So where are they actually building that value? So most of you use Google or other Amazon services, and we don't pay much except for maybe Amazon Prime. So those services are not actually free. They're getting money by getting our data and driving value out of that. So that's a new kind of a trend in our century, 21st century, and it's going to be transformative. What the oil did 100 years ago, data is going to do the same with this application of analytics. So something about the agenda. So we'll cover the Honest journey from being descriptive to predictive and prescriptive. So status quo at Honest, what was Honest before INSNAP came in? Why did they acquire us? The data initiative which we took in order to solve the problems at Honest. So, and then how we did go about doing that in terms of alignment of team, culture, and technology. We sparking the technology and then followed by conclusions. Before we jump into the details, how many of you guys you are in decision-making process in your companies? Few of those. And how many of you guys use data for that decision-making process? So, okay, not that bad. So something about INSNAP, just to give a background. So INSNAP was about instantaneous personas. As you can see, so imagine that you install a Twitter app, and if you use INSNAP plugged in as part of the SDK or toolkit, what it will give you, it will actually instantaneously give you your interests. And Twitter will then can match other tweets or groups so that you can subscribe to them instantaneously, beating the cold start problem so that Twitter doesn't have to actually amass the amount of data. So that was INSNAP focus. And it was a multi-tenant big data machine learning API to drive monetization and engagement. So Honest company, what is Honest about? So has any one of you guys used Honest products? Okay, there are few. Okay, so some of them know. Maybe the baby product, right? So Honest is a mission-driven company, and what they actually make trusted and effective products across a wide range, including baby, beauty, personal care, home care, supplements, or vitamins. And they have this bundle-based e-commerce model for so that you can subscribe to it and get the things which you want, for example, diapers, bundle, or home essentials. So status quo at Honest, it was like pretty siloed in terms of data. So basically, they have each team or engineering team or growth team. All of the team had like a bunch of data silos, and they did not have a way to get the data into one place, which inhibited them to actually do analysis as a whole. And similarly, the organization was also siloed, or they were like verticals with no cross-functionals as far as the data is concerned. So data integrity. So that was one of the biggest pain point, the inconsistency in data. So that, for example, if you want to go generate a report from one path and go from then come to another path, you actually get different results, which kind of make the data integrity questionable. Like, hey, what's going on? And there's a chance of losing credibility for the business folks. So that was another problem. So this was a great potential to become data driven, and because of that, we look at the legacy architecture. Sorry, it's one slide. So just taking a look at the legacy architecture, like what was it before INSNAP? So if you see like a e-commerce app which is getting like clicks and orders, and now data is being written to MySQL database, and then starts the replication, which is shown in orange here. So it's kind of a daisy chain of replication to master slave at level 1, and then it goes out to other slaves. And the reason they're doing it is because they want to kind of have more computation and I/O power, and the way it is done is that by creating those arrays of slaves. But that actually couples the whole system and makes it harder to change or modify and test and validate. It also makes it harder to scale. And the developers here are spending most of their time either in making sure the system is up and running, or they're just like fulfilling business people request, because business does not have access to the data which the way they want it to be. So INSNAP acquisition by Honest, INSNAP found a new home, and it was like a perfect match, like a match made in heaven. And that's how we came to INSNAP along with my other co-founders. So the data initiatives we took at INSNAP, so the first one we did was break away data and organization silos. So this was very fundamental. So essentially build a data warehouse which could collect the data from multiple silos and make it available in one place, which could be used to analyze further. And similarly for our organization silos, we actually created a cross-functional team, which I'm going to talk about further. Instrument logging, that's very fundamental, like event logging, when I say logging, fundamental to get the data from the actual source, so that this kind of can be used for traces of what the users are doing with the system. For example, their searches, their page views, add to carts, other kind of events, and it provides you like the means to get the data, right at the source. Using ML, to turn data into actionable insights. So understanding the patterns of the data, and then what those customers are, how to segment those customers using some predictive analytics, and also like predicting, for example, other applications, LTV or churn for the customers. Cross-functional team. It's very important to have cross-functional teams which are clear in their goals and responsibilities, have the right context, and which are aligned to the business goal. So this is like a paradigm shift of operations which we embarked upon. And the self-serve model, which basically gives the power back to the decision makers, so with the right tools according to their level of skills, so they can actually use that to get more insights out of data, analyze the data more, and then make decisions on that. So another thing was the culture that was basically that needed to be required, because just throwing out a technology at a problem does not solve a purpose, or it actually does not yield the result which we are looking for. So the culture is like, okay, we need to like be in that mindset in order to execute our data initiatives. So anything which cannot be measured cannot be improved. That's like, basic law, which principle which we follow for any data-driven initiative. Transparency around decision making. Any executive, let's say it's because of his or her gut feeling, makes a decision which is not backed by data, that might not fly and it might not be sustainable. So we need to have a transparency around decision making so that we actually make products which are more customer focused. Empowerment. So give the user the ability to get access to the data, and also like train them so that, for example, using data camps, we actually had SQL primers. Then we had, so people can actually learn some SQL and apply that stuff to analyze data. Similarly, our visualization service, Domo, we actually train people on that so that they can actually use the workflows within those and make further useful analysis. Fail fast. So this is like a typical agile approach which we need to make in order to be data-driven. So it should be scalable, it should be repeatable, and we should kind of do divide and conquer approach. So break down into smaller stages and use those stages to kind of constantly improve, having a feedback loop with the customers or with the stakeholder involved, and takes further steps out of those. Data drives the Omni. This is like how our Omni commerce looks like. So for example, we not only sell to online customers, but we also sell to brick and mortar stores. So this is like gives us a unique position to actually have data from multiple sources, multiple touch points, and essentially like get that data into a place where to build like advanced analytics on top of it. So for example, for operations, it's very important to know as to how the orders are getting fulfilled. And for that, we actually created a data mart, which actually had data from different sources within the operation fulfillment pipeline, and made it available in near real time to the folks who want to track orders and thus make the customer happy. Now we get the data from indirect sales channels, for example, Costco, Target, and then we have that data available. So, and on top of it, we kind of layer what we get from our ecommerce.com so that we can actually get a holistic view of the customers, including their trace of the calls which they made, also the web chat which they had. So all those touch points needs to be kind of tracked in order to give them this this solution which is like really omni-commerce, which basically means that the customer gets the right experience wherever they are, either they buy online or offline. It's kind of a congruent experience. So we are still working towards that, but we have made a lot of progress by using the technology we have. And it's a combination of data, the user experience, and which basically gets the ROI which we are looking for. So this demonstrate our data platform, how we actually did that. So as you can see, we basically ingest behavioral and transactional data and use it for multiple data silos. For example, we have Localytics, we have data from Costco, which is our offline sales channel. We have data from Facebook for the ad targeting, for the campaigns. So all that data is ingested in, and we use Spark at the center of, which is kind of our workhorse or ETL engine, to get all the data into one place and make it available as a data model which can be used further to, for example, getting predictive analytics on top of it, LTV, churn, service for cross-sell, upsell in terms of recommendation. So we use offline models, we put them into our NoSQL engine, Cassandra, and then we make it available as a service in order to productionize them so that when the user comes in, we are able to give him or her the right recommendation to buy products based on their attributes or based on the insights which we already discover. So there are a bunch of stakeholders here which we actually fulfill. Operation is a big one, which actually we want to make sure that order fulfillment pipelines are getting fulfilled. Marketing and growth, they need to track how their ad campaigns are performing. How is the user acquisition funnel? Is it producing the right and the high quality of people which they are looking for? So LTV feeds into that and helps them to basically get ROI which they are looking for. Accounting is mostly concerned about reconciliation across different systems for revenue reporting. So that's kind of getting the data into one place really helps. Whereas finance is looking for they actually build their e-com model on top of the subscription model which we have, so that they can actually forecast. So they want to make sure that the data there is integral, it is in one place, and it could be relied upon. Similarly, customer service people we can help them make differentiated service or promotions depending on if they already know if the user which called in has a higher LTV or what is their churn, chances of getting chances of being churning out. So all these metrics are made available to the business by giving them the power to make and operate and optimize business. So our new architecture, at 10,000 feet, it has the nuts and bolts in it. We are totally AWS based, and we have basically converted the MySQL database into a stream, as you can see, coming to Spark through Kafka, and then we actually use S3 for storing our all of the data, making a data lake around it, so that whoever needs the data, which is not in our data warehouse, which is Redshift, we can make it available. And then on top, you see there are clicks coming in via our logging server, which is based on Spray. And it also has other services, for example, search, recommendation, so that people who are looking to search something, they actually are getting the results on honest.com. And similarly, we have real-time dashboard, which is to give people, customers, internal customers mostly, to track the orders fulfillment pipeline, which is basically like based on the NoSQL store Cassandra, which we use to store orders and order states information and give them a real-time view. Our visualization service is Domo, as I talked earlier. So that's like our tool to also become a self-serve in a manner that it actually moves the data into its own database, and it has workflow engine so that it can be used to basically create reporting cards on top of it. We found Spark to be 10x faster easily than the legacy system. It helps us a lot in terms of adapting to different source sinks and sources. And we use it primarily for scoring our models. We usually train them. For example, data scientists love Python, so they usually use some kind of a tree-based algorithm, XGBoost or something similar for predictive analytics for our LTV churn. And then once they are done, then we actually use it for scoring historical data using that model. So Spark actually helped us a lot in there. We have hundreds of devices. Our data lake at S3 is like in tens of terabytes. We have 100 million events, even more monthly events. So this is like our new architecture, which is like a step up using the state-of-the-art technology, what we actually had earlier. So why Spark? And Databricks, I'm going to talk about that. So one of the problems we faced was all this code was written in MySQL. And if you know, it's like very declarative, but at the same time, it's very hard to maintain and extend. So we actually moved to more like a Scala-based code, having lots of boilerplate code and utilities so that it could be used in the team, and the code could be reused and with lots of test suites built in. So that gave us ability to scale teams and the code at the same time. So Elastic Store and compute, I think the way the Spark is built is it makes compute separate from store. So your story could be in S3, and then you can spin up a cluster anytime you need, get the data in from S3 and do some transformations and then store it back to S3 or write to Redshift. So that is like another piece which helped us kind of evolve quickly, iterate quickly as our architecture or platform supported it. Collaborative and interactive. One of the cool things about Databricks, which we have been using in our platform, is that it provides those notebooks in which you can run the Scala code or Python code at the same time. So data scientists love Python, whereas data engineers' favorite language is Scala. How many of you guys use Scala here? Okay, quite a bit. So that's great. So we actually write those functions in a manner that those can be called by those notebooks, so that data scientists don't have to rewrite those functions, which are already taken care by data engineers. Similarly, it's very interactive. So the dashboard gives you like a visualization or charts, so you can explore the data quickly and make some intuition, get your intuition to actually see what the results are and understand the correlation and causation right off the bat. So this is very helpful. We found it really helpful as part of our analysis. Infrastructure efficiency. So at the time when we were required by Honest, we didn't have much resources. The team was very small. So there was no dedicated DevOps. Even as of now, we don't have a dedicated DevOps. And the way we achieved that efficiency was to use Databricks to manage our Spark cluster. So it's very easy to spin up and down those clusters and even auto scale. I hope the serverless feature, which kind of takes off, which is due this week, according to a keynote presentation today, that really will help even further. So it did actually give us like a jump start in our approach and optimize our resources to actually look at the data and the value and not like, hey, I'm worried about my cluster going up or down, or it's not doing the things which I want, the job dependencies on that. So all that is kind of taken away by using Databricks. So our journey of descriptive to predictive, so at that time, there was only like data analysts, which were mostly trying to answer the questions, hey, what has happened to that campaign? What is the ROI? Let me just like, give you the results to other PMs and stakeholders. But the data scientists, we actually were able to add a huge business value by order of magnitude by actually not only predicting what will be the new ROI or LTV of the new user, but also like in more like a prescriptive or advisory mode where they can see like they can actually allocate the budget of marketing in TV versus display. For example, that kind of recommendation or advisory role can only be achieved by further kind of following that journey and enhancing our analytics platform to actually support that. So we are kind of on that journey and we are doing it. So it really helped achieve a lot of great results. So conclusions, the hall is getting filled up now, but I'm kind of at the end. I can take on more questions. So invest in infrastructure and people. This is like a very important takeaway that in order to basically build an analytics self-serve platform, we have to have the right underpinnings of the infrastructure. And we have to train people to basically give the power back to them in order to use the tools effectively and efficiently to do the analysis and create this culture where people can ask questions, can raise more queries, and essentially work together with decision makers along with data scientists and data engineers to solve a problem. So embed analytics. So analytics should not be like afterthought. It should be like part of the business processes. It should be it should be thought right ahead when we actually start some product. So that should be the way that we actually execute our business. And similarly, the organization, the cross-functional teams are very fundamental in bringing that paradigm shift of becoming data-driven. Working in silos does not kind of help in that, because the organization has to move those levers, understand those levers, and essentially like take the next steps and iterate over it. And then last and final, keep calm and let the data speak. That's what I say. Thank you.
Anyone have any questions? We have a couple minutes.
You talked a little bit about the cultural change, right? And like data analysts versus data scientists. So I guess when you came, I mean, when you started building this team, did you find that there were certain, was there any like cultural resistance, and like what tools, like you mentioned notebooks, visualizations, what tools work for the data scientists as opposed to like data analysts or data engineers? Like, do you have any thoughts on that?
Yeah, sure. So when we came to Honest, so basically there were no data scientists. There were only data analysts with very limited tools. So for example, all they had was a homegrown or homegrown app, a portal, which provided them some real-time stats. And then the Domo was like getting into the picture with the visualization tool. So that really helped. But basically, only the data they had access to was the reporting or revenue data. There was none of the data which was available to them, the behavioral data, nothing like that. It was like just existing in one silo, in one huge MongoDB, which is 10 terabytes. And nobody can even query the index because it's like so large that it doesn't it's not even sustainable query. So we had to like change that paradigm shift that not only give them the tools, but also like change the underlying technology to help them grow fast. And also train engineers, for example, data engineers, to move away from 100% SQL, writing SQL code, which is not manageable. And then create this cross-functional team which works very closely with analysts, finance analysts, growth analysts, and data scientists and data engineers to basically ask questions. Because it's a combination of top-down and bottom-up approach in which analysts are mostly like trying to find from top-down, like what has happened, whereas data scientists are taking the approach of bottom-up, like what if, they're coming up with scenarios or questions from the actual, looking at the data, the causation and correlation. So that actually create the right culture mixed together to actually form a solution which actually does benefit business. Because if you just make a model which predicts something, that's not going to work either. You have to basically apply that the way the analysts or the way the PMs are using to optimize business operations, for example, ad campaigns or SEOs. So that all goes hand in hand together, and they have to sit and collaborate very closely. So Domo did help a lot, I have to agree. Databricks gave us another jump start because another view, but was primarily used right now by data scientists and engineers. We are still in our way to extend that. I hope that answers your question.
Thank you very much. Okay, we are having a little break to switch for speakers. So thank you very much.
All right.
That was a great talk.